Hi, welcome to Layman's Guide to Cracking the Coding Interview. I'm Jox, and today we're going to be dealing some of the tree structure problem. So basically, I would say it's a tree traversal problem. So we have the post-order tree traversal. The way it works is the left, right, and the root. So for example, we have this tree as a given tree, and we have it root as a 1. On the left, it's 2, 3, so forth to the 4, 5, 6, right? And then if we are trying to do the post-order traversal, we always follow the left, right, and the root. So here, the leftmost node here is the 4. So first we're going to be outputting the 4, and then the right should be the 5, and then the 2. So it's going to be 4, 5, and then the 2. So this is going to be the left. Now we need to go to the right. On the right hand side, we have the leftmost subtree as a 6, and then it's going to be the 3 and then the 1. So finally the output would be 4, 5, 2, 6, 3, 1. So there we go. This is going to be the output, 4, 5, 2, 6, 3, 1. And the way to write this program, I'm going to debug it and then show it later, but just for the quick glance, I'm going to show you the code as well. So here we have. So as usual for the tree problem, always we check if the root is none or not. So if the root is null, then we simply return the true. If not, then we call the recursive function, the same function, post-order traversal. Then we pass as a left node as a root, and then we have a cache to store the value so that we're gonna print out and see how it's gonna. So we have to basically find out the output as 452631. So that's how we're gonna do. And at first we're gonna put the call the recursive function with the left tree and then with the right tree, and as long as we hit to the null, we just append the name of that root node, name of that node. So simply in this case, we're gonna come to the 4, we're gonna check it to the left is a null, return true, and then again check to the right, it's gonna return null. Then we're gonna append the value. So n.name is gonna be the 4. So this is gonna be appended on our cache and so forth. It's gonna traverse all the way, and this is gonna be the post-order tree traversal. I'm gonna show you in the code. I'm gonna run that later, but just for the illustration purpose, I have the simple snippet of the code here. And then now we have an in-order traversal. We have the same tree structure as usual, but the way of traversing is in order. So in the in order, it's gonna be left, root, and then the right. So in this case, the leftmost is the 4, and then the root gonna be the 2. Earlier we have left, right, and root node, but now it's going to be the left, root, and then the node. So here 4, 2, 5. So this entire going to be the left node, and then now we have to go to the node. So node going to be the 1. Now onto the right hand side. So on the right hand side, the leftmost is a 6 and then the 3. And by explaining that, we have a code snippet as like this. As usual, if the node is a null, then we simply return the true. Else we initially call the in-order traversal, then we put the left tree. So as soon as we hit to the null value, we can append the name of that node into the cache, and then only we're gonna call the in-order traversal again, the recursive, but we just put the right after that. So in that way, we're gonna be getting the left and then the root and then the right. So that's how we're gonna do, and we're gonna have the output 425163. So that's gonna be for the in order. I'm gonna show you while I debug that. Now we have the pre-order traversal. So by looking at it like with the given tree, so we have a 1, 2, 4, and we have the 1, 2, 4, and then we outputting the 5. So 1, 2, 4, 5. Somehow it looks like a DFS, depth first search, right? So in fact, pre-order traversal is also the DFS tree traversal in fact. So literally it's the same thing, but just like we have a different naming. So this is the output, exact output, what we're gonna have it for the DFS. And as well as we do have a DFS, I just make it slight difference so that we can see the difference. So simply in the tree traversal, we just try to print the value, but when we do the DFS, we try to check if the node has been visited or no. So that's the only difference. I rewrote that in the code section. So if you go here, it's a simple. So whenever we see the node, we just put it into the value because we said root left and then the right. So we do the same thing, and then we call the recursive function pre-order traversal, and then we pass the left, and after that we again call the recursive function, then we pass the right value. So this would be the output. So this is exactly the DFS, but I do have a DFS here, but only difference I have it here is that I put it the visited one. So if a node is not visited, then only we perform this function, else we don't need to. So in that way, like this would be useful for other use cases, but just to traverse, both would be the same. The pre-order or the DFS gonna be the same, the output gonna be the same. So here we have the same thing as we did earlier. We put the value into the cache, and then we call we also mark the node as a visited, right? So wherever we visit, we just mark it as a node. Then we call the DFS and the left and then the right. So we pass out the parameter, the visited function, so visited list, and then the cache. And simply we print the value of the cache, which is going to be the 124536. That's the DFS. Now we have a BFS. So in general, we call the BFS as a as a like a level order traversal as well, because we print or we traverse through all the nodes in each level. So it's starting from the first level. At first we have the node 1, so we traverse to the 1, and then we have a 2 and 3, like a left and the right away. So we go to the left and to the right, and after that we go to another level. So this level have a 3 nodes, so we have a 4, 5, 6, and the way to do that is by using the queue. So we whenever we see the node, we just put it into the queue, and then we like put all the items, all the nodes that's the child to the parent node into the queue, and after that we visit all the queue, we go to each of them, and again we visit all of them. So that's how we traverse the BFS. So this is the solution for the BFS. So here I have a BFS as a root node and the queue. I pass the parameter as a queue, and as usual, whenever we start out for the tree, we always check if the given node is null or not. If so, we just return false. So I also created the stack. It's an empty stack. So every time we see the value, we put to the stack. So that's what I did. So we put the value of the node name into the stack. So then I have a queue. I open all the trees into the queue. So now we check if the length of the queue is 0 or no. So if not, then we call the one of the node or the v, one of the temporary variable, as the initial node into the queue. So here in this case we have the initial as 1, because this would be in the queue because we added that onto the queue. So this is going to be the 1. So then we get the node as a v, as a node as a 1. Then we remove that value from the queue. So the queue is empty for now, but we need to check these two conditions. So left is not none, and if the name is not in the as a stack. So if it's not, then we just append the value of name of that node into the stack, and then the left node onto the queue. So forth for the right node as well, and then we iterate until our queue is empty. So once the queue is empty, then we just finally output the stack. So stack will have all the values. So it's going to be 1, 2, 3, 4, 5, 6. So that's all for the tree. And then let me run the program. So here I have a program. So I built the tree first. I created the node structure, and then I created the trees. So n gonna have all the trees. So at first we're gonna be using the post order traversal. So I'm just gonna put the breakpoint here. so that I can debug and we could see more easily here. So now we have an n. Let me just close this. So this is a tree. So we have a node name as a 1, and we have a right and we have a left. On the left we have a 2, and the left has the right and the left, so that has a 5, and on the right hand side is the 4. So it's literally the tree that I drew right over here. So then I debug this. So we're now gonna put the value of 2 into the we're gonna be putting into this function, and we're gonna be calling. So now we're gonna be putting 4. So now we check the left of the 4. Is it empty? Yes. So that's why we're gonna be returning the true value here. Now we're gonna be checking a right hand side of the 4. Sorry, it's gonna be empty. And then now we finish left and the right. So now we add the 4 again. So now we're gonna be executing this line. So now under the cache, we're gonna be having the value of that node. So that's the 4. So here we have it. It's a 4 right over there. So same executes. So now it's gonna be for the 5, 2, and so on. So by the end, let's see the cache. What's gonna be the value for the cache? Let me remove this breakpoint. So now we have a 4, 5, 2, 6, 3, 1. So that's for the post order traversal, and same goes for the in order. And let me put the breakpoint here. Let me throw this away. So now we have the entire tree at the first. Then we are calling this recursive functions with the n as a root as a left. So it's gonna go to, now it's gonna go to the 4. Till now we were at 3. So when we hit to the 4, it's gonna check on the left hand side. So the left is null, so it's gonna print true. Then now execute this line. So that one have a 4 again. Then we're gonna call this function again. Now on the right hand side, it's gonna be calling the right hand side of that 4. So literally that's gonna be the empty. So that's why it's written true. Now it's gonna be calling, going back to the same one. So now we are here again onto the 4, and we append that value. So now we have 4 and 2, because earlier we were at 4, we got back, right? So that's when we got back, we have to execute the line again, and we are putting the value into the cache. So now we are at the 5, because we're calling the 5, because n.right gonna be the 5. So now we're gonna have the value 5 right over there. Earlier we just had 4 and 2, now 5. So process repeats until we hit to the end. So let me put the breakpoint here. I'm gonna throw this away. So here we go. So 425163 as we mentioned earlier. So this is for the in order traversal. And now we're gonna have the pre-order. So this is similar to the DFS as I mentioned earlier. So it's just going to be traversing until we hit to the end of the tree on the left hand side first, and then to the right hand side. So that's how we traverse the DFS. So I pretty much doesn't need to explain this one. And after this we have a DFS, the same thing, and the BFS. So I just stop this and then I run the program to see the output if we are having the right answer or not. So here we go. So now let me expand a little bit here. So we have a post order traversal. The value that I mentioned in the slides earlier, 452631. So this is our given tree, and for the post 452631, like that. And in the in order traversal we have a 425163, 425 left root right, and this was left right root. So this is the pre-order. So the pre-order is more like a DFS. So we have the same value for the DFS and the pre-order. And then finally the level order traversal, that's a BFS. So 1 2 1 2, 3. So level 1, level 2, level 2, and then the level 3. And here we could see 1, 2, 3, and exactly we have that answer. So that's how we traverse the tree. I think it's pretty much easy to understand this tree structure problem now. Thank you.